this problem we have we are going to chapter 8, that is conservation of momentum. And this problem is like this. It's say you have a bullet. The bullet is moving with velocity 300 meters per second. 300 meters per second, the velocity is 300 meters per second. And the bullet, after the collision, the bullet is being seen moving at 150 meters per second. Initially, the mass, the M, capital M, is at rest. So it's asking you what is the magnitude of the velocity of the mass M, and it's moving to the right or moving to the left. This is a very interesting question, if it's moving to the right or moving to the left, because initially I have momentum, and the momentum is conserved. What is the momentum initially? Is the momentum of the bullet plus the momentum of the mass M. What is the momentum initially? The momentum initially is a vector, and it has a quantity, and the momentum of the bullet is the mass of the bullet by the velocity of the bullet, plus the momentum of the block, the capital M, is the mass of the block by the velocity of the block. Okay, initially, the data that I have is that the mass of the bullet is 10 to the minus 3 kilograms. The velocity of the bullet is 300 meters per second. And let's say that it's moving to the right, so it's moving in the I direction to the right, plus the mass of the block. The mass of the block is 1 kilogram, but the velocity of the block initially is 0. So this amount, this vector, the total momentum initially have to be conserved. So how much it is 3 by 10 raised to the 2 power by 10 to the minus 3 in the I direction. So I cannot change the positive I direction. The final momentum will go in the positive final direction, in the positive X direction. So 3 by 10, this is 0.3 I. 0.3 watt kilograms meters per second. Okay, so there are momentum initially in the amount of 0.3 kilogram per meter per second. What is the final momentum? The final momentum have the same expression that this one, or like this one, only that the data is different, not because the mass has changed. It's because after the collision, the velocity, the vector velocity have changed. So the mass of the bullet is 10 to the minus 3. The velocity of the bullet is 1/2. And he's moving to the right, so it's in the positive direction, plus the mass of the block is 1, and the vector velocity is an unknown, the vector velocity, but I know that this is equal to P initial. And what is P initial? P initial is 0.3 I. So what is the vector V of the block? What is this vector? So I will solve it. So I will say VV plus, let's say 150 is 1.5, 10 raised to this 2 power. So it will be 1.5, so it will be 0.15 when you multiply by 10 to the minus 3. Okay, so 0.15 plus V sub B equals 0.3I. 0.15, so the velocity V sub B is 0.3I minus 0.15I. So the velocity of the block of the capital M, of the mass, will be 0.15i. And this is the result. And let me see if it says something like this. Wow, it doesn't say anything like this. So let me think if I made a mistake. The bullet goes from the block almost instantaneous and emerges with 50% of its original speed. What is the speed of the block just after the bullet has emerged? So where I did the mistake, let me see if I did the mistake somewhere. In a calculation, maybe 300 is 3, 10, is 3, 0.3, yes, it's 0.3. Okay, and this is 0.15, 0.3. I don't see where I made the mistake. So you need to tell me. You need to, it's 10 grams, it's 10 grams, oh, it's 10 grams. This is 1 gram, it's 10 grams, so you made the calculation correctly. So it's 10 grams, it's 10 minus 2. Okay, 10 grams, 10 grams. Sorry, so it will change, let me go, I do it again. This will be, instead of 0.3, will be 3. Well, you do it again. P initial will be 3i instead of 0.3. And this will be 1.5. So the velocity will be 1.5. And let me see. 1.5, oh, is here. Should be this one, the correct answer. Okay, so you redo it again. I'm sorry that I didn't put the 10 grams. 10 grams is 10 by 10 minus 3. Sorry, I thought in 1 gram, not 10 grams. So you redo it and you will find this result. Let's go. The area, the next one. Impulse. What is impulse? Impulse is force during the time, delta t. And what produces the force acting on the time? Well, the force Fx acting on the displacement produces a change in the kinetic energy. But the force acting on the time produces a change in, so they have a vector here. Let's go to write it correctly. The force F acting on the time delta t produces a change in the momentum. This is a vector equation, and this is an scalar equation. So, but in this problem, indeed, they look very like scalar equation, even this, because they say the force on the x direction by delta t is the change in the momentum in the x direction. So it's px final minus px initial. So again, it's the same idea, and this is called the impulse. The impulse is forced by delta t. In the same way that this is named the work, this is the equivalent to the work, but this is an scalar and this is a vector. But in this way, this magnitude, the impulse in one dimension, can be thought as a scalar number. So what is the impulse here? The impulse is the force by delta t. So you choose a small delta t here, delta t, and the area is the force F by delta t is the area of the rectangle. And what is the total impulse? The total impulse, because the force is changing, the total impulse is the total area below the curve. So let me now read what it say. The problem is say a forklift that I don't know what it's a forklift. Push a mass of 100, a crate of mass 100 kilograms, starting from rest, so initial velocity is 0, with an horizontal force of magnitude F, and no, it's on the picture. We know the force. The force vary with not with space like other problem. It vary with time. What is the instantaneous velocity of the crater at time t equal 10 seconds? What is the instantaneous velocity at t equal 10 seconds? So you will say, okay, the force Fx by the impulse, the total impulse, is the area. So the area below this curve is mv final. The area is mv final in the x direction minus mv initial in the x direction. Initially, vx is 0. So I have to find the area. So the v final x is the area below the curve divided by the mass. Oh, what is the area? So the area is the area of a square of a rectangle 10 by 5. So here 10 by 5, here there is 50 units of area. How we measure these 50 units is newtons per seconds. This is the area, 50. And here on the triangle, on this part is a triangle. The area is 1/2. The base is 5. From 5 to 10, there is 5. By the height is 10. So the impulse is negative in both cases. So the area is negative. Oh, so it's 50 is 25. So I have 50 plus 25, 75. But indeed I have minus 75 because the force is negative. So the area is negative. So the final velocity V will be the area minus 75 divided by the mass. And the mass is 100. So it will be minus 0.75 meters per second. And let's go to see minus 0 meters per second, and should be the D, okay? Should be the D. Okay, see if I have made any mistake. I'm doing the problem quickly. So it's a impulse, a super dart of mass 20 grams, traveling at velocity 350 meters per second, straight steel plates and an angle of 30 degrees. With the plane as shown in the figure, it bounced the plane same angle, but at the speed 320 meters per second. So he changed the speed. It was at 350, and now the magnitude of the velocity is 320. So he has changed the magnitude of the velocity, but has not changed. Yeah, it has changed the magnitude of the velocity. What is the impulse that the plate gives to the bullet? So let's go to do it. So this is the wall. Then the object is coming with velocity 350 meters per second in this direction, with 30 degrees with the wall. This is the wall, 30 degrees and 60 degrees. So this 30 degrees here. This is the 30 degree. 30 degrees is this here also. And he's leaving back with 30 degrees here. Here is 30 degrees. But the magnitude of the velocity is smaller. it is 320 meters per second. So the momentum do like this. The pi, the initial momentum coming, this momentum is this one with the angle with the wall 30 degree. This is the momentum. Okay, and this is 60 degree. It has the magnitude 350. So this is 350, sorry. 350. So the momentum, the initial momentum have 350, let me erase here, 350 cosine of 60 in the x direction, and 350 cosine of 60 in the x direction, and in the y direction it has 350 sine of 60. This is the opposite side of the 60. So this is the momentum. This one, plus this one is the pi. This is the pi, the initial momentum. Okay, what is the PF? So this is the pi. I wrote it like this, 350 cosine of 60 plus. What is the PF? The PF is this one. This is the PF. It's moving with velocity now 320. So m by v. So sorry, m by v. I make a mistake here. M by v. What is the mass? Mass is 20 grams. So it's m, the initial momentum is this one, m by the vector velocity. This is the vector velocity. And the final momentum is m by the vector velocity. Okay, this is the vector velocity. So P final is this vector. You know, because you have done vectors before, that if you analyze this construction, this vector PF, this is 30 degree, this is 60 degree if you want. So the vector PF is a vector have mass by vector velocity. The mass is, I don't remember how many grams. The mass is the grams that say. And the vector velocity is the vector that has the magnitude 320. So it will be 320 if I see with the sine cosine of 60 in the I direction, but negative because it's coming to the left, plus 320 sine of 60 in the positive j direction. This is PF. This is the vector PF, m by bf. I did express the vector PF in terms of this angle 30 degree. So in terms of this angle 30 degree, the vector PF is something going up in the j direction, or how much? 320 cosine of 30 in the j direction, and something going to the left. How much? This one is 320 cosine of 30, sine of 30, the opposite sine of 30, but is going in the negative direction as the I. So I have done the same vector in different ways, but it's the same vector. It's exactly the same calculation. So this is the momentum PF. And what is the change in momentum? Is the impulse. So if you see a picture, you would see the momentum PF, PI initially like this, coming through here. And PF is a vector that is coming like this, but it's have a smaller length because the mass has not changed, but the velocity has changed. So the vector have a smaller length than this one. So the change in the vector P is this vector, the change in P. So F by delta T is here, and F by delta T is the change in momentum. So let's go now to find F by delta T. This is what the question is asking. What is the F by delta T? The change in momentum. So let's go to write it. So I have PI. Who is PI? It was 350, is the mass. You make the multiplication now. Is the mass, 350 is the magnitude of the velocity. I put it in terms of the angle. This is 60, and this is the 350. So it was cosine of 60 in the I direction plus 350 sine of 60 in the J direction. This was the PI, and the PF is the mass by the velocity, but the velocity was like this. You remember it was like this. It was 300 instead of 50, 320. And this angle was 30, and this angle is 60 then, because everything is 90. So I wrote it like this, 320 cosine of 60 in the minus I direction, because this vector is made of this vector plus 320 sine of 60 in the J direction. This is the momentum. And what is the change in the momentum? PF minus PI. So let's go to make the change. The change will be M. So I will make the differences between PF and PI. PF is M minus 320 cosine of 60. So this is PF is M minus PI. The component PI is M 350 cosine of 60. And this is everything in the I direction. Plus the change in PF in the J direction. This is M 320 sine of 60 minus M 350 sine of 60. And this is in the J direction. Perfect. So now I will plug in numbers and how I will change the impulse. In the answer, I think that I saw a number. You see, I saw this number. So he's asking really about the magnitude of the impulse of the place. So I will go, and once that I have the change in momentum, this amount, you have to plug in the mass M here. Please do it. The mass M here, so let me, the mass M here, so M is here, okay? And now that you have found the correct vector, what you do is the magnitude of the change. And the magnitude of the change is the force by the delta T. But they're asking about the impulse. And the impulse is the change in the momentum. So what is the magnitude? The magnitude is the square root of this square plus this square. If you do it, you should find the one of the answers here. So please try to finalize the problem. See See if I have done, if you find the correct solutions, and if not, let me know and I'll do it again. Sorry that it's too late, so tired. Okay, in elastic collision, let's go to do the number 4. 1,200 car mass, so I have an object of 1,000 moving at 15.6 meters per second. It collides with a stationary object of 1,500 kilograms. So its velocity is 0, and he is moving 1,200 kilograms, is moving with velocity 15.6 meters per second. Perfect. If the vehicle locks together, what is the combined velocity? If they lock together in a collision, and always it happens that the momentum is conserved. So after the collision, both objects, the 1,200 and the 1,500, they move together with certain velocity v. And what it's asking is, what is this velocity that the two objects are moving together? They ended sticky one to the other. It's an inelastic collision where the kinetic energy is not conserved before the collision. Is not the same amount that after the collision. Before the collision is bigger amount that after the collision. So here it says what is the velocity of the object. So pi, the total momentum, is conserved, is equal to the final momentum. The total momentum initially is the mass of the first object by the vector velocity of the first object plus the mass of the second object by the vector velocity of the second object, everything initial. And this should be m1 plus m2 by the common vector velocity. And this is the velocity that they are asking me. So in the x direction is happening everything. M1 is 1,200 kilograms. V1, the magnitude of V1 is 15.6. So everything is happening on the x direction plus 0 because the velocity is the object 2 is at rest, equal m1 plus m2, 1,200 plus 1,500 by the common vector velocity of the object. So the magnitude of the velocity v is 1,200 by 15.6 divided by 1,200 plus 1,500. And if you do it, you should find one of the answers, one of the questions that one of the possible options that here. Let's go to find an elastic collision. A block of mass m, 3.6, moving on a friction surface with a speed v1 equal 9.3 meters, makes a sudden perfectly elastic collision with a stationary block of mass m as shown in the figure. Just after the collision, the 3.6 kilograms block recoil with a speed of 2.7 meters per second. So this one is moving with 2.7 meters per second, but moving to the left 2.7 meters per second. So initially, this is the first mass, 3.6 kilogram, is moving with velocity 9.3 meters per second. It makes a sudden perfectly elastic, as shown in the figure, just after the collision. This is the 3.6 kilogram moving with velocity 2.7 meters per second. What is the velocity? What is the speed of the other block? What is the velocity? So in an elastic collision, there are two equations that you can use to solve problems. One is the conservation of momentum. The momentum is conserved, so all the momentum that exists before the collision is equal to all the momentum of the two particles that exist after the collision, final. So this is the first things that you need to know for a collision. In a collision, the momentum is conserved before the collision at one instant before the collision and 1 instant after the collision, the forces that are between the two objects are so big that even if there are external forces, the momentum you can consider to be conserved. In the case that there are external forces to the interaction force of the two bodies that are colliding, the momentum is not conserved, of course. But in the case that there are only two objects and they collide and there is no external force, there is no force external in any direction, only there are internal forces acting on them, the internal force does not produce on the system a change in the momentum. So a change in the total momentum in 1v1. So this is the third law of Newton's law that we have studied and we have done the principle, etc. Okay, and the second condition is that in an elastic collision, all the energy of the two bodies, kinetic energy of the first plus kinetic energy of the second, before the collision, initial, before the collision, they have the same energy after the collision. 1/2 m1v1 squared plus m2v2 squared final. So we have two equations. The first equation say m1v1. This first equation say m1v1 plus m2v2 initial equal m1v1 final plus m2v2 final. This is the final momentum PF, the total final momentum of the two particles. So I have two equations. So I have a system of two equations. But in this particular case, this is 0 and this is 0 because initially the mass m2 or the mass capital M is at rest. So the first equation will read like this. M1v1 initial equal M1v1 final plus M2v2 final. And the second equation for the conservation of kinetic energy will read 1/2 M1v1 initial square will be 1/2 M1v1 final square plus 1/2 M2v2 final square. So the kinetic energy final of the second with the kinetic energy initial of the first particle, the sum is the final kinetic energy is equal to the total kinetic energy initially. Solving this system of equations is what we did during class. The solution was, this is an interesting solution, the solution was, if I remember well, v1f, the final velocity of the object 1 and the final velocity of the object 2. Wow! In terms of the initial velocity of the object 1, v1I. I think it was something like m1 minus m2 divided by m1 plus m2. And here I think, if not, you go to your textbook, m1 plus m2. So these equations are the solution of this system of equations. So the first equation say conservation of momentum, the second equation say conservation of kinetic energy because the collision is elastic, and these two equations are the solution to the system of two equations. So the problem is just to plug in numbers. So v1f, what it will be? M1 minus M2. M1 is 3.6. M1 is 3.6. B1 is 9.3. Let me see, just after the collision, the 3.6 kilogram It doesn't say the mass of the other one. Just after the collision, recoil with them. What is the speed v of the other block? Okay. Wow. Entonces, so v1f is recoil, and it has a velocity. Here it say the initial velocity is 9.3, and the final velocity is minus 2.7 because it says that recoil. So remember 9.3 is minus 2.7. So I will go here and I will write 9.3 for the initial velocity, and I will write m1, m1 plus m2, so v1 final is minus what? Minus 2.7. Minus 2.7. This is the final velocity. I know n1 is 3.6. 3.6 plus minus m2, this is an unknown, and n1 is 3.6 plus m2. So this equation will allow me to find m2. So find m2 for this equation. Okay, this equation says minus 2.7 equals 3.6 minus m2 divided by 3.6 plus m2 multiplied by 9.3. So divide by 9.3. So make the solution and find m2. So now what it's asking me is about v2f. So v2f is 2 times n1 divided by n1 plus m2 by v1i. I know all the data now. 2 times 3.6 kilograms divided by n1, 3.6 plus m2 that you found it, multiplied by v1i. Who is v1i? v1i, it was 9.3 meters per second. So this is the final velocity. So the problem is that here, using the first equation of the solution, the equation A, using equation A, you find m2. You plug in here m2 and you find v2f. And the problem is solved, and you have to check which one is the correct solution. So, which one is the correct solution? Can I guess which one will be the correct solution? Well, no, I cannot guess. Because I don't know the mass. The mass of the, you have to calculate. Okay, that's all. Let me. There is one more problem here. Energy and momentum. Let's go to do it. Okay, so now we have to find this initial velocity, and the impulse is the change in momentum. The final momentum is 0. The initial momentum is the two masses moving with velocity v sub I. So how I will find v sub I? I will say, okay, between the point V of maximum compression of the spring of a constant K and the point A before the collision, here at the point A where there is no compression, this is the compression just before touching the spring, the mechanical energy is conserved because all the forces are conservative, so the mechanical energy at the point A is equal to the mechanical energy at the point V. At the point A, there is kinetic energy, but there is no potential energy because the only potential energy that I can have is the spring, is the elastic potential energy, but at the point A, there is no elastic potential energy because the spring is not compressed. So the kinetic energy will be 1/2 m plus m v squared plus potential energy 0. At the point V of maximum compression, the kinetic energy is 0 and the potential energy is K by decompression x squared divided by 2. So the 2 will cancel and the V squared will be this amount. So this is the V initial. This is at the point A. This is the V initial. So this is the magnitude of V initial. So I found it. So the change in momentum is minus the mass by the initial velocity. Is the change because P final is 0. So if I plug in the magnitude of V sub I here, square root of this, and I plug in the numbers, you plug in the numbers, the square root of K, 1500, M plus M, 10 a la minus 3 plus 4, multiplied by the compression. If you found this, you should find one of the possible options of the problems that the impulse is newtons per meter, so you should find newtons per second, newtons per seconds. You should find one of these answers. Well, I don't want to make the calculation, but well, you do the calculations. Let me see. Let me check it that I didn't make any mistake. Okay. This is approximately the impulse is minus 4. The minus sign is because it's a vector. The impulse it goes to the other direction, but it doesn't matter. He makes the magnitude. This is like 4. This is a square root of 1,400 divided by 4. 1,400 divided by 4 is like 350 more or less. 350, yes. And this is 9. 8.9 is like 9 by 10 a la minus 2. So let me see. 4 square root of 350 can be like 17, 20 is 400. So it could be like 18 by 9 by 10 a la minus 2. You do the exact calculation. I'm just doing 4 by 18 is like 20. It's like 4 by 18 is 20 by 4 is like 80. 80 is 76 by 9 by 10 raised to the power minus 2. And 75 by 10 this is like 700 by 10 a la minus 2. This is like 7 newtons per second. 7, 8, I don't know. You do it. Let me see what it says here. 7, 8 should be this. Well, maybe you should do it to discover which one is the correct solution. And that's all. I see you on class. Good luck. I hope you